Alright, in this video I'm going to talk about why noble gases are stable and why they don't form compounds. So what I mean by stable is I mean that noble gases do not bond with other elements. This is almost always true. It's not completely true, but it's pretty good. And so what I mean by don't bond with other elements then is I mean they don't give or take electrons. So to answer the question why noble gases are stable, what we really need to answer is why they don't want to take any electrons from anybody else or why they don't want to give any electrons to anybody else. So as an example here, I'm going to use the simplest noble gas that I can, which is neon. Neon has an atomic number of 10 and an atomic mass of 20, meaning if we think of this in terms of its Bohr-Rutherford diagram, we have 10 protons and 20 minus 10 neutrons. Then, if we are going to put in our electron orbitals, we'll put in the first shell, and then the next shell, and assuming we're starting with neutral neon, that means that our number of protons and number of electrons are the same. So I have 10 protons, so I'm going to have 10 electrons. So there's 4, 6, 8, 10. So now, if we want to consider this molecule a little bit more simply, and we want to think about what it looks like in terms of whether its chemical properties, then we remember shielding an effective nuclear charge, and we see that on the inside here, we have 10 protons and only 2 inner electrons. So 10 minus 2, this overall nucleus appears to have a charge of plus 8. And then around the plus 8 are 8 electrons. So the simplest part of this problem is why it won't give up its electrons. If we see that it has 8 electrons sitting around a charge of plus 8, and we recall that effective nuclear charge has a range of plus 1 to plus 8, what we can see here is that we have the highest possible effective nuclear charge. What this means is no other atom is going to come around with a higher effective nuclear charge, and so no other atom is going to come around and effectively steal an electron from this. So we can say since the effective nuclear charge is very high, the atom will not give any electrons. So again, we've covered half the bottle here. We're talking about why this thing is stable or why it won't have any chemical reactions. And what that means is why it won't give or take electrons. We've addressed why it won't give electrons. So why won't it take any electrons? And this is a little bit more confusing. I'm going to just scroll down here and get myself a little more space to work with. Again, just to redraw what I just had there, I have my plus 8 and my 8 electrons. So you might mistakenly think that that plus 8 effective nuclear charge should be very attractive to incoming electrons from any other atom, say from a metal or something like that. And that seems pretty reasonable. It should be. And so you might assume that it would steal electrons from other atoms, and that's how it would react. But there's a problem. The problem is if there's some other electron and he comes and he tries to join this atom, there's no more room left in this shell. And so what has to happen is a new shell has to be formed. So when this electron comes, he can only come into this shell because this shell is full. The problem is that out in that outer shell, now all these inner electrons are available for shielding, or they're going to keep this electron in its new shell from seeing that nucleus fully, that full +8. What that means then is that the effective nuclear charge that was +8 is going to get reduced. This +8 is going to combine with this -8, and that's going to leave us with an effective nuclear charge of 0. This effective nuclear charge obviously is not attractive. So what that means is, so no more electrons can be attracted in. So if you want to think of it this way, the +8 level is full, and the next level has to do additional shielding, and it gets, this level has an effective nuclear charge of 0. And so it's very happy to have its 8 in that full shell, but if you have to start another shell, it's very unattractive. There's no attraction for any future electrons. And so since the new electron would have to start a new shell, it will not be able to see the effective nuclear charge of +8, so it will not be attracted by it. It will instead see an effective nuclear charge of 0, meaning it is not attracted in. So I might have repeated myself a few times there, but I think this is kind of a slightly difficult to understand and confusing topic, but it's important. It tells us why atoms attract in electrons until their shell gets full, and then why they don't just keep attracting electrons and make bigger and bigger shells, and why that happens. So it's kind of important. But again, that's why noble gas, but I thought it's a little confusing, so I just wanted to take a little care there. That's why noble gases are stable. They don't give any electrons, because when they just have their own electrons, they have that +8 effective nuclear charge, very attractive, they won't share. But they also don't take electrons, because the next electron would have to start a new shell, and that new shell wouldn't see the same effective nuclear charge.